Scientists have found that a foreign star once visited our solar system, altering the course of some comets and ice particles. This indicates that the stellar guest has left its mark. Despite its very small mass, the unsettling star was sufficient to agitate the objects in the Oort cloud. However, what first caused the glistening invader to join our solar system? What can we learn from this cosmic encounter, and where is the star now? Talk about enduring. Despite the fact that the two Voyager probes were launched over 45 years ago, the spacecraft have persisted in their mission across the wide reaches of space. The identical sister probes, the furthest outposts of civilization, have now even traveled into interstellar space, separating themselves from the Sun by billions of kilometers. Right now, Voyager 1 is 16,466 astronomical units, or AUs, far from our host star. Knowing that an astronomical unit is equivalent to the average distance between the Earth and the Sun, which is approximately 150 million kilometers, we may calculate that this amounts to approximately 2,463 billion kilometers. However, since the distance between the probe and our luminous life-giver is only 13,761, a U or 20.59 billion miles, Voyager 2 is even closer to the Sun. However, the Voyager probes would not have been visible if you had gazed up at the night sky 70,000 years ago, but you might have seen a bright red dot in the firmament. This was due to a stellar guest that had infiltrated our home system, not because light pollution was non-existent at the time, and the sky was generally much more spectacular than it is now. The visit from the Stone Age star actually arrived in two parts. We are talking about a red dwarf that was given the cumbersome scientific name WISAJ 723 84,651.2 and is most likely accompanied by a brown dwarf. Most people are more familiar with it as Schulz's star. Ralph Dieter Schulz, who was the first to identify the objects in 2013, is also credited with giving the star system its less numerically demanding name. Thousands of years ago, our ancestors and the Neanderthals would have been amazed by a reddish point of light in the sky, because red dwarfs are known to occasionally have catastrophic outbursts. However, when we take into account that the dwarf's combined mass is only 0.15 solar masses, it becomes evident that it truly earns its name despite all of its bright spectacles. Because of this, astronomers initially believed that the stellar lightweight would not have a major impact on the solar system's celestial bodies. However, there were also several irregularities that raised suspicions among the experts. Despite the fact that Schulz's star is currently 22 light-years from Earth, it appears to be hardly moving. Such a so-called tiny tangential motion can be explained in two ways. Either the star is moving away from the solar system again, or it is just about to head towards it. The researchers at the University of Rochester use spectral studies to examine the star's course more closely in order to determine which scenario applies when the star joined the solar system. As it turned out, the measurements evaluations made it abundantly evident that Schulz's star is presently making its final journey through the solar system. On the other hand, this implied that it must have formerly been far nearer the Sun. But just how close? Astronomers simply turned back time to solve this question by feeding a model the star's speed and track data. The outcome of this virtual time travel was that in 98% of the 10,000 orbital simulations, Schulz's star went directly through the Oort cloud 70,000 years ago. In short, long-period comets are believed to originate from the Oort cloud, a fictitious shell-shaped area in the furthest limits of the solar system. Experts believe that the Oort cloud stretches up to 100,000 AU, despite the fact that its presence has not been confirmed. However, the researchers initially believed that Schulz's star did not produce any significant disruptions during its transit through the remote collection of ice and rock particles since, as previously noted, it has a relatively little mass. They might have been mistaken, but more on that later. Additionally, the experts were aware from the beginning that no other star in history has ever approached our solar system as closely as this one. However, in astronomy, close still refers to 52,000 AU or 0.8 light-years. However, Proxima Centauri, the star that is currently nearest to the Sun, is 4 light-years away, which is 5 times farther from our core star. A change of heart in astronomy. The idea that close star passes once had a major impact on the trajectories of long-period comets is not new, even though the masses are modest. Simply put, no known representation that would have satisfied the astronomical conditions for it existed for a considerable amount of time. It should be mentioned at this stage, nevertheless, that not all academics agreed that Scholz's star's visit had no impact whatsoever on its environs. As we now know, Carlos de la Fuente Marcos of the Complutense University of Madrid was one of these skeptics. He and his colleagues thus conducted a detailed evaluation of the orbits of over 340 objects that follow very uneven trajectories across the solar system. In their simulations, the specialists identified the apparent paths of origin of these hyperbolic objects. In essence, it was anticipated that they would be dispersed equally throughout the sky. The Oort cloud, after all, encloses the solar system's interior like a sealed shell. But reality presented a totally different picture, defying all prior beliefs. A statistically significant grouping in one direction was noted by the experts. This indicates that paths pointing toward the constellation Gemini are described by most of the fragments that were studied. This indicates that Scholz's star was closest to that area of the Oort cloud 70,000 years ago, which is also where the objects originated. To put it mildly, the astronomers do not believe that this is a coincidence. Instead, the Stone Age star passage must be the reason for the collective orbital alignments. Ultimately, Scholz's star is so well aligned with the timing and place of these orbital disruptions that they practically beg for a direct relationship. According to the experts' estimations, the celestial body might have even approached the Sun a bit more closely than first believed. Instead of 0.8 light-years, the analogous distance might have been 0.6. It must have literally thrown a number of ice fragments from their original orbits at this shortened distance. However, what is the current state of affairs? As previously stated, Scholz's star has now returned to a distance of 22 light-years from the Sun, and it seems likely that the next star will not follow suit for some time. Theoretically, only roughly once every 9 million years will a star come close to the Sun to within 52,000 astronomical units, AWS, or less. However, one star is already a little hurried. Not everyone must follow the rhythm of the star speeding toward the solar system. Rogue stars are outliers that don't care much for the overall galactic beat, even though the majority of stars orbit the Milky Way in unison. Gliese 710 is one of these rogue stars, and it is currently headed straight for our solar system. Unlike Scholz's star, the specialists in this instance concur right away that the star guest will produce significant disturbance in the Oort cloud. The 0.6 solar mass star is still 62 light-years away from the Sun today, but it should have gotten closer to the Sun in 1.1 light-years in roughly 1.3 million years. But in this case, it's also thought to be causing the Oort cloud's objects to spiral up so much that a full-fledged comet shower will approach the inner solar system. Additionally, this raises the possibility that one of the uncontrolled galactic rockets will strike Earth. Accordingly, scientists predict that there will be at least a 5% increase in the frequency of comet impacts on Earth. We can only pray that none of our distant descendants are a gigantic boulder that could wipe out the entire planet. However, there are still a few days to 1.3 million years from now, and NASA has previously demonstrated with its DART mission how a targeted hit can alter a celestial body's trajectory. We'll now demonstrate how to personalize the videos on your homepage. To ensure you never miss another post from us, click the subscribe button, give it a thumbs up, and click subscribe. See you soon.